Whatever you studied yesterday, uh, in that I'll ask some questions, give me answers. Is Java object-oriented programming language? What is object-oriented programming language? Which supports all principles. How many principles are there? 4. What are those? If any language that support these 4 principles, that language is called object-oriented programming language. If you want to use these 4 principles, what we require? Class and object. Class and object are called language constructs. Language constructs. Language purpose released. Principles are just released based on theoretical concept, but language purpose, class and object released. Okay. So class and object are called language constructs. What is class? Collection of variables and methods. Will it class occupy memory? No. Will it file occupies memory? Yes. What is an object? Instance of a class. Instance of a class. What is new? Dynamic memory allocation operator. What it will do? It allocates a memory to variables. Okay, variables. Methods also allocated. That is separate. I'll explain further. JVM architecture will be there. At that time, you'll see. Say class name and brackets is called constructor. What constructor will do? Constructs the object. So new constructor, if you write object created. Okay. Can we create object without object reference? The type of object is called anonymous object. We can also call unreferenced object. Can we create object reference without object? That object reference, what it contains? Null. Null. What is null? Object literal. How many categories of literals are there? 6. What are those? Integer literals, floating point literals, character literals, string literals, boolean literals, object literal. Okay. How many categories of data types are there? Categories 2. What are those? Primitive data types, reference data types. How many primitive types are there? 8. What are those? What are reference data types? Arrays, strings, classes, interfaces, these all reference data types. Now, so outlines of a class you studied. Now, inside the class, very depth you are going to learn. Now, first, class is a collection of variables and methods. Okay, variables and methods also I'll explain. Suppose I want to maintain 5 employees data, 100 students data. How many classes we have to create? 2 classes. One is employee class, one is student class. Then objects are 5 employee objects, 100 student objects. Okay. See, yesterday I explained object like a building, class like a plan. Like that I explained. You take anything in the world, that is object. That is object. There was one plan. So you take anything in the world, there is nothing but object. For example, it is a monitor. It is an object. It is an object. Why monitor is like this only? There was one plan. There was one plan. Suppose keyboard, it is one object. Why keyboard is like this only? There was one plan. Why mouse is like this only? There was one plan. You take anything in the world. You take anything in the world, that is nothing but object. For that, one class will be there. Nothing but plan will be there. Say, why monitor rectangle shape only? Why it is not circle? There was one plan. Okay. You take anything in the world, that is nothing but object. That is nothing but object. For that, one plan will be there. Okay. So that is class and object relationship. Class and object relationship. Now 100 employees data if you want to maintain. 100 employees data if you want to maintain. How many classes required? One class. How many objects required? 100 objects required. Okay. 100 buildings if you want to construct. Same type of buildings. How many plans required? One plan. 100 buildings. That type. Class object relationship. Okay. With class and object knowledge only, you can understand encapsulation, abstraction, inheritance, polymorphism. Okay. Before learning principles, class and object very depth required. Now, next heading, variables. Note. Next heading, variables. A variable is a container that contains data. A variable is a container that contains data. A variable is a container that contains data. This is already you studied. There are three types of variables. First one, instance variables. Second one, class variables. Third one, local variables. There are three types of variables. First one, instance variables. Second one, class variables. Third one, local variables. There are three types of variables. There are three types of variables. First one, instance variables. Second one, class variables. Third one, local variables. Now, here also again objects, classes, everything comes. It is not completed a class and object. Inside also you are learning. Class is a collection of variables and methods. Variables you are learning. Variables if you want to use, class required. Again, we only class, no use. Object required. You will see again class and object again also. First notes I will give. Note instance variables. Instance variables. Note a variable that is defined as a member of a class is called as an instance variable. A variable that is defined as a member of a class is called as an instance variable. A variable that is defined as a member of a class is called as an instance variable. I'll explain, just write the notes. Memory allocated to instance variables whenever an object is created. Memory allocated to instance variables whenever an object is created. Instance variables are stored in heap area. Instance variables are stored in heap area. A variable that is defined as a member of a class. A variable that is defined as a member of a class is called as an instance variable. Memory allocated to instance variables whenever an object is created. Instance variables are stored in heap area. What is heap area? I'll explain. Next. Second one, class variables. A variable that is defined as a static member of a class is called as class variable. A variable that is defined as a static member of a class is called as class variable. A variable that is defined as a static member of a class is called as class variable. Memory allocated to class variables whenever class is loaded. Class variables are stored in method area. Class variables are stored in method area. A variable that is defined as a static member of a class is called as class variable. Memory allocated to class variables whenever class is loaded. Class variables are stored in method area. Just note down, I'll explain. With the diagrams, with the programming, I'll explain. Third one, local variables. Third one, local variables. A variable that is defined inside a method is called as local variable. A variable that is defined inside a method is called as local variable. A variable that is defined inside a method is called as local variable. Memory allocated to local variables whenever method is called. Memory allocated to local variables whenever method is called. Local variables are stored in stack area. Just as it is, write it. I'll explain with the diagrams. I'll explain with coding. Then you'll get a clarity. A variable that is defined inside a method is called as local variable. Memory allocated to local variables whenever method is called. Local variables are stored in stack area. Is it over? Writing is over. Note 1. Local variables cannot be static in Java. Local variables cannot be static in Java. Note 2. No global variables in Java. That means outside the class. No global variables in Java outside the class. Local variables cannot be static in Java. No global variables in Java. Nothing but outside the class. Is this completed? Here, you observe instance variables stored in heap area. Class variables are stored in method area. Local variables are stored in stack area. These three nothing but memory blocks inside a JVM. JVM memory, RAM memory only. RAM in CPU, two memories will be there, no? Primary, secondary. Primary memory nothing but RAM. Secondary memory, ROM, hard disk. Okay. Say without RAM, we cannot work. Without RAM, we cannot work. Without hard disk also we can work. But without RAM, not possible. Okay. Now, even when you switch on computer, operating system, it is in C drive. When you switch on computer, it is loaded into RAM. In the RAM only working. So hard disk is permanent storage mechanism. That's it. Okay. But all operations are done in RAM. That's what it is called primary memory. That is only main memory. Without hard disk also we can work on computer. It is possible. Without RAM, we cannot work on computer. RAM is primary memory. Main memory, RAM only. All operations are done in RAM only. Okay. Here, you observe. I opened here browser. Three applications I opened. It is browser. It is Zoom software. It is Notepad. Then what will happen? In a RAM, this browser purpose some memory allocated. This Zoom software purpose some memory allocated. This Notepad purpose some memory allocated. Memory allocated. Like that, Java program purpose some memory allocated. That memory we are calling JVM memory. That JVM memory divided into 5 blocks. In that 5 blocks, 3 blocks you have seen. Just note down. JVM memory divided into JVM memory divided into the following blocks. JVM memory divided into the following blocks. First one, heap area. Second one, method area. Third one, stack area. Fourth one, native stack area. Fifth one, PC registers. Program counter registers. Heap area, method area, stack area, native stack area, PC registers, program counter registers. JVM memory divided into the following blocks. Heap area, method area, stack area, native stack area, PC registers, program counter registers. 5 blocks divided. Okay. In this block, instance variable. In this block, class variable. In this block, local variable. Remaining blocks, while teaching JVM architecture, I'll explain. Okay. Present, it is enough. See, whatever I given notes, these all I'll explain. See, these variables only 3 classes required. 3 classes. Only variables. That much depth required. Because Java, total Java depends on this topic only. It is the most important topic. Okay. Here, first, how to identify which is instance variable, which is class variable, which is local variable, I'll explain. Next, memory allocations, I'll explain. Next, how to access those variables, I'll explain. After that, life of the variables, I'll explain. After that, scope of the variables, I'll explain. After that, when we have to select instance variable, class variable, local variable, I'll explain. Instance variable place class variable, if you write, what will happen? Class variable place instance variable, if you write, what will happen? That is also I'll explain. Okay. That is you are going to learn. Now, first of all, identification. How to identify? Say, there are three types of variables. First one, instance variable. Second one, class variable. Third one, local variable. Member of a class, instance variable. Static member of a class, class variable. Inside a method, local variable. Local variables, you cannot write static. No global variables in Java. Outside the class, we cannot write variables. Those variables are called global. Now, one code snippet I'll write. One code snippet I'll write. Not program, only code snippet, not complete program. File, open. Is it over? Here, class name, main method, it is common for every program. Class name, main method, every program, it is common. Now here, I'll write some variables. You observe. Here, integer a equal to 5. Static integer b equal to 10. Say, here one variable are written, here one variable are written, integer c equal to 15, static integer d equal to 20, integer e, don't write, I'll give time for writing, integer e equal to 25, static integer f equal to 30. Like this are written. According to notes, you observe. I'll ask questions, some questions, give me answer. How many types of variables are there? 3 types. What are those? Instance variables, class variables, local variables. What is instance variable? Member of a class. What is class variable? Static member of a class. What is local variable? Inside a method. Say, concepts you have to remember. With that knowledge, you have to write programs. Programs, no need to remember. That is remember. Okay. See, what students are doing, this concept they won't remember. Program, first line to last line, they'll by heart. That is wrong way. Wrong way of learning. Program, no need to by heart. Concepts, you have to by heart. Compulsory. With the concepts, any program you can write. But programs, if you by heart, whatever I'm teaching, that is only you can write. New program, not possible. Okay. Concepts, you have to remember. Compulsory. Whatever I'm giving these points, no, these points you have to remember. It is compulsory. That's what every day I'll interact, you'll get it. Okay. That's what. Repeatedly I'll ask questions. At that time, respond. Nothing will happen. You'll remember subject. Otherwise, you'll forget subject. If you don't open mouth, you'll forget subject. It will be happen. Because how many points are there you observe? See, about variables only, these many points I given. It is just 50% only. Still 50% points I have to explain about variables. Now I didn't explain. First I'll complete this one. Next I'll give again notes. Okay. Now, while asking, just respond. You'll remember subject. How many types of variables are there? 3. What are those? Instance variables, class variables, local variables. What is instance variable? Member of a class. What is class variable? Static member of a class. What is local variable? Inside a method. Okay. Clear now? Now, here, notes are given. Member of a class. Instance variable. Static member of a class. Class variable. Inside a method. Local variable. Local variables cannot be static in Java. Inside a method, we cannot write static. That is error. No global variables in Java. Nothing but outside the class. Outside the class, we cannot write variables. See, in this code snippet, total 6 variables are written. A, B, C, D, E, F. 6 variables are written. Now, first one, A, it is not valid. B, not valid. Already given notes, no global variables in Java, nothing but outside the class. Outside the class, you cannot write variables. Outside the class, non-static also error, static also error. Now C. C is a member of demo class. C is a member of demo class. It is valid. This is which variable? Instance variable. D is a static member of a class. It is valid. Which variable? Class variable. But only difference, static keyword. What is static till I didn't explain, but you can learn. Possible. I'll explain. Because total Java like that only. Welcome program only class is there. But class you are learning these many days. After these many days you are learning. But Java like that only. Not only Java, any subject you take in software like that only. Okay. So what is class? I didn't explain, but welcome program already completed. With the welcome program only class you have seen. See, observe. Every day you are writing public static void main string args. Till I didn't explain that line. Till I didn't explain. Every day you are writing system.out.println. That line after 1 month you will learn. System.out.println. That is not possible to explain today. Object-oriented programming should be completed. Then only you will understand that line. Only that line half an hour lecture is there. System.out.println. Not only Java, C language also. Printf is a function. After 1 month, you started function in C language. Hash include std.h. That is also after 1 month you learn. Like that only. Okay. Now, what is static in further session you will study, but you can understand. It is possible. Here, C is a member of demo class. It is called instance variable. D is a static member of demo class. It is called class variable. Now, E inside a method, local variable. Now, local variable cannot be static in Java. It is not valid. Okay. Now you observe this C called as instance variable. This D called as class variable. This E called as local variable. Right, this one? So variables identification I given. Okay. Is it over? See, outside the class, non-static also error, static also error. Outside the class, variables we cannot write, error. Inside the class, non-static, instance variable, static, class variable. But why we are calling like that, you'll understand. Today only you'll understand. And inside a method, local variable. Local variables, if you write static, error. So, total how many variables I written? 6. How many valid? 3. 3 valid, 3 not valid. Okay. Now, suppose one Java project, if I show in that project, which are instance variable, which are class variable, which are local variables. Can you identify now? Possible no? If I show one Java project, in that project, which are instance variable, which are class variable, which are local variables, you can identify. It is possible. Okay. Say, C is a member of a demo class. It is called instance variable. D is a static member of demo class. It is called class variable. E inside a method, local variable. Okay. It is instance variable, it is class variable, it is local variable. Okay. Like this, you can identify. Inside a method, static keyword, if you write, error. Outside the class, if you write variables, error, not valid. Now, not valid, these two, I'll remove. This is not valid, I'll remove. This variable names, I'll change. Now, X is a which type of variable? Y is a which type of variable? Z is a which type of variable? Local variable. Suppose year 10, year 20, year 30, like this are written. Now, memory allocations, I'll explain. Memory allocations, I'll explain. Now, identification clear now? Identification. X is a which type of variable? Y, Z. That is clear now? Now, memory allocations I'll explain. Here, it is instance variable. When memory allocated to instance variable, notes are given. No, memory when it is allocated. You see the notes? Whenever object is created. So, memory allocated to X whenever an object is created. When memory allocated to class variable? Whenever class is loaded. When memory allocated to Z? Whenever method is called. Instance variable, which memory block it is stored? Heap area. Class variable, which memory block? Which variable? Which block? Method area. Local variable, stack area. Now, once again, I'll ask questions, give me answer. This is which type of variable? X is which type of variable? Instance variable. When memory allocated? Whenever an object is created. Which memory block it is stored? Heap area. Y. Which type of variable? Class variable. Which memory block it is stored? Which memory block? Method area. When memory allocated? Class is loaded. This is which variable? Local variable. When memory allocated? Whenever method is called. Which memory block it is stored? Stack area. Okay. See, X, Y, Z. X is instance variable. Memory allocated whenever object is created. It is stored in heap area. Y is class variable. Memory allocated whenever class is loaded. Which memory block it is stored? Method area. Z is local variable. Memory allocated whenever method is called. It is stored in stack area. This is, remember, I have to explain. Memory allocations, I'll explain. Now, if you write like this, if I execute this program, suppose, first one more question I'll ask, already you studied. Class name is demo. File name is test. Is it valid or not valid? Valid? Sure? Valid. It is valid. How to compile this program? java-c test.java. Then how to execute? Java demo or Java test? Give me answer. Demo. Class name. Whenever you compile like this, dot class file generated for class test.java, you are compiling. Then demo.class generated. Demo.class generated. This demo.class file we are executing. Then you'll get output. Now, this is you already studied. How to compile is java-c test.java. How to execute? Java demo. Okay. Suppose this file name is demo.java. How to compile? Java-c demo.java. Next, Java demo. Okay. Java-c demo.java, Java demo. Java-c demo.java, Java demo. Compilation depends upon file. Execution depends upon class. Okay. Now, here class name demo. Now also Java demo. Previously also Java demo. Nothing but this program you are going to execute Java demo. Like that only you are going to execute, no? While executing, first this demo class loaded into JVM memory. At the command prompt, you will write Java demo. Then demo class loaded into JVM memory. Then this memory allocated. So here execution priority is there. Note down. Execution priority. Execution priority. First one, class variables. Next, static blocks. Next, main method. First one, class variables. Second one, static blocks. Third one, main method. Execution priority. First one, class variables. Second one, static blocks. Third one, main method. See, whenever you run the program, JVM, it will search for class variables. First, class variables memory allocated. Class loaded, class variables memory allocated. JVM, it will search for class variables. Suppose class variables are not there. Then it will search for static blocks. Static block nothing but, further you will see, static keyword, open brace, close brace. It is called static block. That is further session comes. Suppose, first it will search for class variables. Class variables are not there, static blocks. Static blocks are not there, main method. Like this, it will search order. That is priority. Welcome program. While writing welcome program, there was no class variable. There was no static block. That's what directly main method executed. Okay. But in this program, class variable is there. So first class variable executed. Next it will search for static blocks. We don't have static blocks. Next main method. So first this is executed. Next main method executed. Okay. Now this is priority. Execution priority. Say, whenever you execute the program, first it will search for class variables. Class variables are not there. It will search for static blocks. Static blocks are not there. It will search for main method. Main method also not there. execution not started. Okay, it is compulsory. Okay, that is priority. Now remaining all depends upon main method coding. Whatever you are going to write according to that order. But this is default order. After executing main, inside a main method, whatever you give an order, that order executed. Remaining statements. Okay. Now, in this program, say, first what will happen? See, demo class loaded, open brace executed, class variable memory allocated, main method called, open brace executed. Whenever method is called, local variable allocated, but X variable not allocated. X variable memory allocated whenever an object is created. If you don't create object, no memory for X. If you don't create object, no memory for X. Say, demo class loaded, open brace executed, static int y equal to 20 executed, main method executed, open brace executed, local variable executed, but memory not allocated to X. Suppose these two lines, if you write here also, first what will happen is demo class loaded, open brace executed, class variable memory allocated, then main method called, local variable allocated. So these two outside the methods you have to write, inside a class you have to write, but that is before main method or after main method, anywhere you can write. Outside the methods, inside a class, instance variable with a static keyword, class variable, inside a method, local variable. Like that we can write. So if you write like this also valid, if you write like that also valid. Okay. Now, here, what's the difference when we have to use instance variable, when we have to use class variable, when we have to use local variable? I'll explain. Not completed. First, memory allocations I'll explain. Demo class loaded, open brace executed. Repeatedly I'm explaining. Listen with more concentration. It is not so easy. You observe up to day before yesterday and yesterday onwards. You observe how it is. Class is different. No? Day before yesterday, up to day before yesterday class, whatever you have seen, C language type. But yesterday onwards, complete different. No? That's what. Listen with more concentration. Total Java, this topic only important. Whatever you studied before object-oriented programming, that is C language concepts only. From here onwards, you need to put more efforts. It is not so easy, you observe. Not so easy. Okay, you need to put more efforts. See, listen with more concentration, online students. Listen with more concentration. End of the session, I'll clarify your doubts. See, demo class loaded, open brace executed, static int y equal to 20 executed, main method called, again int z executed, but X memory not allocated. X memory allocated whenever an object is created. Suppose I'll create object. How to create object? Yesterday you studied, no? Object creation syntax. Syntax to create an object. First, class name. What is the class name here? Demo. After that, object reference. Suppose D1 equal to new. Class name brackets. Then object created. No? Okay. See here, demo D1 equal to new demo. If you write object created, then memory allocated to X. One more object I'll create. Demo D2 equal to new demo. One more time memory allocated. In the program, for you appears 1x, but how many x's will be there? 2 x's will be there. That is depends upon number of objects, number of copies created. If I create 100 objects, 100 x's will be there. But for you appears one only. Plan appears one only. Buildings n number of you can construct, no? Like that. That's what I'm comparing with real time, real world example. Then you will get a clarity. Plan, one plan appears, but based on same plan, 100 buildings also you can construct, no? Like that. There x1 only appears, that is plan. Here objects, buildings. Okay. Every object separate copy. Every object separate copy of instance variable. So write this point. Return execution priority. Next, separate copy of instance variable. Separate copy of instance variable exists for every object. Separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. Only a separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. Separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. Separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. Say, instance variable depends upon number of objects, number of copies created. But class variable, one copy for all objects. Okay. Suppose if I create 100 objects, how many copies of X created in that program? 100 copies. How many copies of Y created? One. Okay. Now, listen with more concentration. Here, if I execute this program at the command prompt Java demo, you'll write, then demo class loaded, open brace executed, Y memory allocated, main method called, open brace executed, Z memory allocated, object created, X memory allocated, again object created, again X memory allocated. In this program, how many copies of X is there? 2 copies. How do you know? 2 objects are there. How many copies of Y? 1 Y. Clear, no? If I create 100 objects, how many copies of X? 100. How many copies of Y? 1. Okay. Now, when we have to use instance variable, when we have to use class variable, when we have to use local variable, I have to explain, not completed. What is the difference? Now, one difference you have seen. Separate copy of instance variable exists for every object. Only one copy of class variable exists for all objects. Okay. Now, up to here, it is not a complete program. It is a code snippet. With this memory blocks, I'll explain. Memory blocks. Now you observe here. I'll ask some questions. Give me answer. Here, what is int? What is int? Data type. How many categories of data type? 2 categories. What are those? Primitive data types, reference data types. How many primitive types? 8. What are those? What are reference data types? Arrays, strings, classes, interfaces, dash, etc. Now, int. What is int? Data type. Is it primitive data type or reference data type? Primitive data type. What is Z? Variable. Is it primitive type variable or reference type variable? Primitive type variable. Is it instance variable or class variable or local variable? Clear, no? Now, what is demo here? Class name. What is D1? Object reference. Here, what is new? Dynamic memory allocation operator. What it will do? It allocates a memory to variables. Yesterday I given like this, but yesterday types of variables I didn't explain. That is the reason notes I given like that. But it allocates a memory to instance variable only. It will not allocate to Y, it will not allocate to Z. New allocates a memory to instance variables only. That's what. One more point, write it. New is called as dynamic memory allocation operator, and it allocates a memory to instance variables. New is called as dynamic memory allocation operator, and it allocates a memory to instance variables at runtime. New is called as dynamic memory allocation operator, and it allocates a memory to instance variables at runtime. So what new will do? Allocates the memory to which variables? Instance variables. See, put efforts, work hard for this topic. Later Java, remaining Java, nothing. Very simple. If you are perfect in this topic, it is hard appears. I'll accept. Work hard. If you don't understand, ask me. I'll repeat once again also, but you have to learn. See, new is called as dynamic memory allocation operator, and it allocates a memory to instance variables at runtime. See, this new allocates a memory to instance variable X. That new only allocates a memory to instance variable X. That is while running Java program allocated. Okay. Here, what is this one? Constructor. What constructor will do? Constructs the object. Constructor constructs the object. Okay. Not only creating object, many concepts are there. In constructor, separate topic is there. At that time, very depth. Now here, one more time, I'll ask question, give me answer. What is int? What is Z? What is demo? What is D1? Now, my question, carefully listen and give me answer. What is demo? What is D1? This demo is a class name. Can I call data type? Can I call data type? Think yourself, answer right or wrong, whatever it may be, give answer. Now, 1 minute. What is int? What is Z? What is demo? What is D1? Now, can I call data type? Yes or no? How many people answer yes? Online students? Those who didn't give answer, that means your answer no, or you don't want to give answer. How many people answer no? Just raise your hand. Okay. Same. You studied just now repeatedly 3-4 times. Also, I asked questions. Once again, I'll ask. How many categories of data types? 2 categories. What are those? Primitive data types, reference data types. How many primitive types? 8. What are those? Byte, short, int, long, float, double, char, boolean. What are reference data types? In that list, class is there, no? Can I call data type? Yes. Class is a data type. Reference data type. Okay. Now, this demo, we can call it as data type also. This object reference, we can call it as variable also. Whenever it is called class, it is called object reference. Whenever it is called data type, it is called variable. Just note down. Class can also be called as Class can also be called as reference data type. Object reference can also be called as reference variable. Class can also be called as reference data type. Object reference can also be called as reference variable. Class can also be called as reference data type. Object reference can also be called as reference variable. Class can also be called as reference data type. Object reference can also be called as reference variable. Yesterday you studied what object contains, what object reference contains. Object contains data. Object reference contains hash code. So what D1 contains? Hash code. Reference type variable contains hash code. Primitive type variable contains data. That point also not done. Primitive type variable contains data, whereas reference type variable contains hash code. Primitive type variable contains data, whereas reference type variable contains hash code. Primitive type variable contains data, whereas reference type variable contains hash code. Primitive type variable contains data, whereas reference type variable contains hash code. Now, see how many points you observe? Many points are there, no? All you have to remember, compulsory. Then only you can understand. That's what this topic is most important. You put efforts, work hard, remember subject. Otherwise, tomorrow class also you may not understand if you forget. Concept, class to class relation will be there. This concept to next concept, relation will be there. See, here, that's what repeatedly I'm asking. Now, what is int? What is z? What is demo? What is d1? Can I call it is data type? Can I call it is variable? No. Is it primitive data type or reference data type? This is primitive data type or reference data type? Is it primitive type variable or reference type variable? It is primitive type variable or reference type variable? Primitive type variable, what it contains? Reference type variable, what it contains? Is it instance variable or class variable or local variable? Is it instance variable or class variable or local variable? Confusion started. Now, how many types of variables? 3 types. What are those? What is instance variable? Member of a class. What is class variable? What is local variable? Now, here, this is which variable? This is, now give me answer. This is which variable? Instance variable or class variable or local variable? Multiple answers coming. How many people answer local variable? Just raise your hand. Okay. Online students. How many people instance variable? Next. Online students. How many people? Class variable. No one is there. Very good. No class. It is instance variable or local variable. Doubt. Now, what is instance variable? Member of a class. What is local variable? It is inside a method or outside a method. That means local variable. It is local variable. Okay. But I am teaching all students same, no? Any difference I am teaching? No. That is listening power, grasping power, thinking power, different. Okay. Inside a method, local variable. So, this is which variable? Now. Don't forget this all. For tomorrow class, again record. Otherwise, not possible. Tomorrow class also you may not understand. So, see, IT student or non-IT student. IT students also not studied subject like this. Okay. Non-IT also, IT also, now all same. Up to fundamentals only. For all people different. IT, non-IT difference is only fundamentals. But IT students also subject, they didn't study like this in academics. Okay. That's what. Listen with more concentration. Now, memory diagrams I'll explain. See. Diagram I'll explain. Total, how many memory blocks are there? Total 5. What are those? Heap area, method area, stack area, native stack area, PC registers. Present we required 3. Here, heap area. See, first method area, stack area, heap area. Don't write. I'll give a time for writing. Don't write. I'll give a time for writing. Listen with more concentration. Listen with more concentration. Don't write. Say. First, what will happen? See. Demo class loaded. Demo class loaded. Open brace executed. Static into y equal to 20. Memory allocated in method area. So, y, which contains 20. Like this, memory allocated. Demo class loaded. Open brace executed. Static into y equal to 20. Memory allocated in method area. Main method called open brace executed into z equal to 30. That is stored in stack area. Z stored in stack area 30. Now, in this line, first new executed. It is a dynamic memory allocation operator. It allocates a memory to instance variable X in heap area. Heap area memory allocated. It contains 10. This constructor constructs the object. This constructor constructs the object. This object referred by reference, that is D1. Now, this object contains hash code. Object has an address. Address mapped into another code. That code implemented with hashing technique. That is called hash code. Hash code stored in D1. D1 is instance variable or class variable or local variable. Which memory block stored? Stack area. So D1 is here. This object hash code stored here. Already told, yesterday told, hash code will write. Instead of that, I'll write arrow. That arrow meaning this object hash code stored there. This object address stored here. One more object created, new. Again allocated memory. Again one more X. Again this hash code stored in D2. Say, in the program and in the diagram, you observe. In a program, how many X appears? 1. In a diagram, how many X's? That is like a plan. This is like a building. Okay, that is like a plan. This is like a building. So plan one only appears. Buildings, many same buildings possible like that. Okay. There for you one x appears. Here how many x's are there? Two x's because two objects. If I create 100 objects, 100 x's created like that. Write this diagram. Write the code also. Complete write it. Code snippet also write it as well as diagram also write it. Write the code snippet, write the diagram. Is it over? Is it completed? Say demo class loaded. Open brace executed. First demo class loaded into JVM memory. Then open brace executed. Then class is loaded means class variable memory allocated. Static int y equal to 20. It is stored in method area. After that, static blocks. Next, main method called open brace. Then local variable memory z allocated. In this line, first new executed. It allocates a memory to instance variable x. X allocated. Constructor constructs the object. This hash code stored in D1. D1 is local variable, stack area. Again object created, again memory allocated. That object hash code stored in D2. D2 stack area, local variable. Now, X, which type of variable? Y, Z, D1, local variable. D2, see, it is instance variable, heap area. It is class variable, method area. These are local variables, stack area. Like that. Okay. Now, how to access them? I didn't explain. How to access them? I didn't explain. You observe. Like this, one instance variable I written, one class variable I written, one local variable I written. But you can write n number of, suppose integer a equal to 15. It is which variable? It is also stored in memory block in a heap area object. Suppose one more instance variable into b equal to 20. Now, in an object, 3 variables will be there. It is one copy I said, one variable I didn't say. Okay. So, if I know here object created, these 3 variable memory allocated. Again object created, again these 3 variable memory allocated. That type. If you write class variable, static y into z, you can write n number of. Class variables also n number of you can write. Local variables also n number of you can write. Okay. One variable I have taken example to understand. You can write n number of variables. Now, when we have to use instance variable, when we have to use class variable, when we have to use local variable, I'll explain. If the value is different for every object, we have to use instance variable. But how to assign different value, that is later we'll learn. But identification possible. See, note down. Use instance variable if the value is different for objects. Use class variable if the value is same for all objects. Use local variable to perform the task. Use instance variable if the value is different for objects. Use class variable if the value is same for all objects. Use local variable to perform the task. Use instance variable if the value is different for objects. Use class variable if the value is same for all objects. Use local variable to perform the task. See, different values if it is required for every object, then we have to choose instance variable. For all objects, same data required, class variable. Any calculation part is there, local variable. Task is there. After performing the task, result comes, then local variable. Now, I'll ask questions, give me answer. It is possible you can select. Employee number. Employee number, which type of variable required? Employee number. Now, first what I given? If the value is different for objects, which variable? If the value is same for all objects, to perform the task, Employee number, for every employee same will be there or different will be there? Then which variable? Instance variable. Few students are giving class variable. For every employee, same employee number will be there? No. Then which variable? Instance variable. For all employees, any same concept is there. We have to go for class variable. Different value, instance variable. Same value, class variable. If any calculation is there, local variable. Now, you can think, you can select possible. Employee number, which variable? Employee name. Employee address. Employee mobile number. Employee mail ID. Employee company name. In one particular company, all people, employees, same name will be there, no? Then we have to write class variable. Like that. Student roll number. Student name. Student address. College name. Class variable. University name. Class variable. C language marks. Instance variable. C++ marks. Java marks. Total marks. Local variable. Calculation is C, C++, Java. You have to add. You have to add local variable. Calculation is there. You have to write local variable. Like that, you have to select. Okay. See, by mistake, instance variable place class variable place instance variable. If you select, many problems will occur. That is the reason only 3 types. Otherwise, all local variable you can write, no? Why these many variables? Why these many concepts? In an application, 1 bit memory also you should not waste. 1 bit if you waste also, then what will happen? For every bit you are paying money. Because internet application, you are not going to place in your home PC. Internet application, you are going to copy in server. Server, you are purchasing some space. For every bit you are paying money. Money also you have to think. And even while downloading time also, if it is more memory occupied, downloading time more. If downloading time is more, people they don't have patience. If you see one website example, you want core Java tutorial, what you will do? You'll open Google, core Java tutorial, you'll type. First link will click. If it is shows loading, will wait. Second website, why waiting? Alternative many are there, no? So 1 bit also you should not waste. 1 bit if you waste, memory occupies more. More memory means downloading also more time. Downloading more time means that site will be outdated. Okay, next other side, very quickly whichever come, that will become popular. That's it. That's what here, every point important only. That's what these many points you observe. Today, how many points you learned, you observe? So many points, no? If you forget, tomorrow will understand? No. You have to remember. Okay? So many points are there. Every point important. Now, once again, all questions I'll ask. Okay? Just give answer. How many types of variables? What are those? Instance variables, class variables, local variables. What is instance variable? Member of a class. What is class variable? Static member of a class. What is local variable? Inside a method. Okay. Can I write inside a method static? No. Local variables cannot be static in Java. Can I write variables outside the class? No. Outside the class is called global variables. No global variables in Java. Okay. Instance variable memory, when it is allocated? Whenever object is created. Class variable memory, when it is allocated? Whenever class is loaded. Local variable memory, when it is allocated? Whenever method is called. Instance variable in which memory block stored? Class variable. Local variable. Total how many memory blocks? 3 completed. Remaining 2. Native stack area. PC registers. PC full form? program counter, not personal computer. Okay, program counter register. You will understand further that is JVM architecture. While teaching JVM architecture, you'll understand that. What is program counter, you'll understand. Okay, program counter register, PC registers. Now, here, this is about variables is studied. What is the execution priority? Class variables, static blocks, main method. Class variables, static blocks, and main method. If I create 100 objects, how many copies of instance variable created? 100. How many copies of class variable? 1 copy. Okay. Class, can I call it as data type? Object reference, can I call it as variable? Object reference is primitive type variable or reference type variable? Primitive type variable, what it contains? Reference type variable, what it contains? Hash code. Okay. When we have to use instance variable, if the value is different for objects. When we have to use class variable, same for all objects. When we have to use local variable, to perform the task. Okay. Student roll number, which variable? Student name, college name, class variable. University name, C language marks, C++ marks, Java marks, total marks, local variable. Okay, like that you have to select. Okay, it is variables not completed. Tomorrow continued. Okay, these concepts don't forget. Tomorrow again required. Okay, we'll see continuation tomorrow. Online students, wait 2 minutes. I'll clarify your doubts. Annu. Objects further also daily comes. Object tomorrow also will write. Yogeshwar. Static block in further session comes. Static open brace, close brace. Dinesh. Yes. Demo is a class as well as reference data type. Gokul. X will be 1, not 1. Every object separate created. Every object separate created. Don't compare with Python. Java different. Yogeshwar. Yeah, I'll explain tomorrow also again. If the value is different, instance variable. If the value is same, class variable. If the to perform the task, local variable. Rakesh, notes uploaded. Just only object-oriented programming you have to upload. Sai Krishna, you can create object outside the class also. I'll explain. Just wait.